Hello, everyone. Good morning. Dear authors and invited guests, welcome to Technical Session 4E. Myself, Ishita Sauryan, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Conference on ICT for Sustainable Development, ICT4SD 2025 Goa, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is being held through today in Goa, India, and the virtual event is being held through Zoom from 17th to 19th of July 2025. I hope you will all enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answer. On 9 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I'd like to introduce you all to the chair for this session. We have with us our session chair, Dr. Shailesh Kahane, who is currently serving as an assistant professor at the School of Allied Sciences, Data Mega Institute of Higher Education and Research, Vartha. With over 16 years of experience in information technology and engineering technologies in science, and he has made a significant academic contribution through research, publication, and mentoring scholars in advanced technological domains. We welcome you, sir. One second, please.
Hello, am I audible, ma'am?
Yes, sir, you're audible.
This is Dr. Shailesh Gahane.
Yeah, sir, just a
Yes.
second. I
Yes.
believe I'm facing some issue. Right. So we welcome you. I'd like to start with our paper presenters.
Yes, sure.
Sure, sir. I'd like to invite our first paper presenter for the session. We have with us Sivakami BU with the paper titled Assessing Readiness for the Adoption of Industry 4.0 Technologies in Manufacturing MSMEs, a Case of Plastic Manufacturers. Ma'am, if you're ready, then you may go ahead.
Yeah.
Yeah.
Oh. I'll just take a second to share my screen.
Sure, ma'am.
Is the screen visible?
Ma'am, I believe I don't see it yet.
Can you see my screen?
Yes, ma'am, it is visible.
So, very good morning, everyone. I'm Shivakami, research scholar at the School of Business, and I'll be presenting about my topic, which is on assessing the readiness for the adoption of Industry 4.0 technologies in manufacturing MSMEs. So, it is in the case of plastic manufacturers for the International Conference on ICT for Sustainable Development. I'd like to acknowledge my guide, my professor, Dr. Suresh, for guiding me throughout this paper. So, moving with the agenda for this paper, I'll be.
Sorry, ma'am. I'm sorry, ma'am. Can you please put your screen in a full screen mode?
Yeah, sure, sir.
Yeah. Click on the three dots.
It's already.
or you can just press F11.
It's in presenter view only, but then I'm just thinking. Okay, wait, sorry about that.
Ma'am, please share your screen once again.
Yes, sir.
Okay.
Yes, fine.
Okay, please go ahead.
I'm very sorry about that. Uh, So, for the agenda for this presentation, I'll be setting up the background and the context for the study, followed by the research gap and the objectives, and also how the research methodology is aligned with the former two, and followed by the findings and the conclusions and the limitations of the paper. So, to set the background and the context, the conversation has shifted now towards Industry 5.0, which relies most probably on the advanced technologies with human centricity, sustainability, and resilience. So, one important question is that how prepared are the MSMEs for all of these advanced paradigms to adopt these advanced paradigms? If they are still struggling to even to match up with the basic requirements for Industry 4.0 technologies. So, from the extant literature, we were able to find that many MSMEs continue to struggle with foundational challenges with respect to infrastructure or even finance and also organizational workforce related challenges. So, all of these would hinder the growth and development of the MSMEs. But on the other hand, they hold a lot of significance. MSMEs being the backbone of economies worldwide, they contribute significantly to the economic development and employment generation. And with the growing interest in the industry 5.0, we might overlook into the current realities, and we might miss out most of the foundational gaps that is prevailing in the current scenario. So there is a need to establish a strong and stable foundation on the and strengthen the MSME's capacities to prepare for the advancements and also to make them ready for the industry 5.0 transition in the long run. So, on the other hand, sustainable manufacturing is very much critical and crucial because it is not just about efficiency and optimizing the production process, but also to reducing the waste and making them for the responsible growth. So the research gap here is that from in the literature we were able to find that the earlier studies have not thoroughly examined Industry 4.0 in depth, wherein there are a substantial amount of literature found in the with respect to Industry 4.0, but most of the existing studies primarily focus on the factors such as infrastructure, workforce related capabilities, digital integration, and strategic alignment to assess the readiness. So there is a on the other hand, the literature has moved towards Industry 5.0 with its significant potential for the sustainable future, adopting its principle without any solid foundation in the Industry 4.0 implementation would be very premature. So here we could see that the theoretical development in this domain is expanding, wherein the ontological, the practicalities remain stagnant. So the application of ontological approaches to ensure the methodological rigor in this adoption studies remains unexplored. So the present study that we are emphasizes on the exclusive technologies and their readiness for adoption, which was not covered covered in the extant literature. And there is also a research gap in applying modeling techniques such as namely fuzzy logic or AHP to assess the implications of Industry 4.0 technologies. So the research objective here is, which aligns with the research gap. So it is to examine the readiness assessment framework for adopting Industry 4.0 technologies in manufacturing MSMEs, evaluating how prepared the sector is to embrace the core advancements. So based on that, the paper has three objectives, three sections of the paper. So one is to identify and examine the enablers criteria attributes for the readiness level, and secondly it is to develop the structured framework for assessing the readiness level for the implementation of Industry 4.0 technologies using fuzzy logic methodology to identify and address the weaker attributes to enhance the readiness level for adopting the Industry 4.0 technologies in plastic manufacturing MSMEs. So the research methodology here, we have once we have identified the enablers criteria and attributes, the research methodology here was to fuzzy logic method. So this method is best suited for cases where there lies an uncertainty or ambiguity in the data. So in this case with MSMEs, it is very much best suited, and the method is effective for capturing language form of data where there are gray scales and enables quantitative evaluation. So this method has three phases. So firstly, it is to identify and classification of enablers criteria and attributes for the adoption of Industry 4.0 technologies. So based on that, this study has 7 enablers, 14 criteria, and 28 attributes. And the phase 2 is the selection of case organization. In this case, we have conducted a study in plastic manufacturing enterprise located in Coimbatore, being the manufacturing hub in India. So in the organization manufactures automobile parts, not just automobile parts, but also agricultural and pharmaceutical plastic components. So the phase 3 is the continuous assessment of readiness and making them to the ready state, extremely ready state. The first two stages are handled in the study, and suggestions are provided to improve the readiness adoption. So, and also the study has adopted the linguistic terms to assess the performance rating, and also the importance weightage, which would be important for this study to determine the readiness level. So based on the literature review, we were able to find the enablers of Industry 4.0 technologies, namely IoT, robotics, AI-driven processes, cloud-based solutions, digital infrastructure, and additive manufacturing. So based on that, we were also able to identify the criteria and attributes, namely for each of these enablers. So this is the final enabler criteria and attribute table. So based on the fuzzy logic method, we were able to identify the fuzzy readiness industry 4.0 technologies of MSME index, which is named as FRITI index. So this was derived by using the triangular numbers, which was then converted into aggregated with the fuzzy performance rating with the fuzzy weightage, importance weightage. So for that, we have derived the number with index, which is 3.66, 5.04, and 6.04. And this was then converted to the linguistic term, back to the linguistic term, using the Euclidean distance method, which brings us to the conclusion that the MSMEs are average ready. So there are scope of improvements to be made in many of the attributes. So to identify those attributes, we found that we applied the Pareto principle, which is at least the least 20%, which was arrived to be 0.6. So the minimum value here is 0.26, as we could see, which is the integration of IoT, robotics, and analytic tools into the IT systems. And these are the 7 out of 28 attributes that have less management threshold. So most of the attention has to be given to these attributes to improve the readiness level. And one interesting fact is that we were able to find that the maximum value is in the usage of AI to predict failures and schedule maintenance automatically in terms of manufacturing MSMEs. So to conclude, the paper has given us two aspects. One is the MSMEs are in average ready status, and secondly, we could find that the weaker attributes such as the weaker attributes would be in the IoT development, IoT deployment, robotics, automation, and digital twin technologies, which has to be given more importance. And also, on the other hand, we have a positive side because the MSMEs are engaging more in respect to AI-driven solutions like detecting the defects, which would improve the quality, and increasing the awareness of adopting eco-friendly and recycling, and also cybersecurity processes using cloud platforms for data storage. So one such information is that this could be again be an reason because of the limited investment capacities, lack of skilled workforce in the sector, insufficient digital infrastructure. So to improve the readiness, we recommend that we target employee training on advanced technologies, affordable and scalable solutions, a miniature version of the plug-in plug-out SaaS-based solutions, and cloud integrations, and government incentives and government incentives and policy support for MSMEs, collaborative efforts to develop locally adopted robotic solutions, and all of these challenges has to be addressed to make those MSMEs and successful transition to Industry 4.0 that would make the transition towards Industry 5.0 smoother. But one limitation of this study is the current study uses one-to-one case organization for assessment, which can be extensively researched in future by incorporating other case organizations as well. And so on the whole, by focusing on the weaker attributes, the MSMEs can transition from average ready to extremely ready, and this would make the transition smoother for Industry 5.0. Thank you.
Okay. So, ma'am, your study is very good and appreciable. I
Thank you.
hope you're doing PhD, no?
Yes, sir.
Okay. So, can you please tell me what are the different manufacturing MSME industries you have considered for your study?
So as of now, we are in the process of, I'm in the first years. So when I first joined, I thought it would be just automobile manufacturing MSMEs.
Hmm.
But then as we move forward, I think it might expand to further, maybe with respect to the pump manufacturing, because in Coimbatore being the pump manufacturing hub, I think we have different grades of pump, being food graded and the water pipeline pumps. So they manufacture a range of pumps. So that is one other sector that I am looking forward, sir.
Okay. And can you please tell me what is pretty index in
Sorry,
your
sir?
study? Pretty index, pretty, FRITI,
Yeah, Fritty.
pretty index.
So Fritty is
How
the
you're
name that
using?
we
How you're using in your study?
Fritty index for my current study.
Yes, yes. How you're using?
So So Fritty index, we actually we take there are linguistic terms that we have for fuzzy importance weights and the fuzzy ratings. The ratings of the case organization. What level are they ready to adopt certain technologies? So we aggregate those two ratings and the weightage to bring in the aggregate numbers. So with that, we get the aggregated numbers. We get the Fritty index. So this is
Okay.
then converted, the numbers are then converted to the linguistic term based on the extant literature that they have, which is called as the readiness labels. from not ready to extremely ready range.
Okay. So should I consider your studies in primary stage right now?
Yes, sir.
You have
Yes.
not made any model kind of thing, है ना?
It is a modeling, but then yeah, I
You are not
think
prepared, no?
yeah, it has not been extensively because I have taken only one case organization. So I
Okay,
think
okay,
it has to be done more efforts to that.
okay. Thank you so much. Thank you.
Thank you, sir.
Thank you, ma'am. Thank you, sir. We'll be proceeding with our next paper presenter. I'd like
Sure.
to invite paper presenter Drisya Murali with the paper titled Assessment for Construction 4.0 Practice Level Using Fuzzy Logic, a Case of Construction Organization. Ma'am, if you're ready, then you may go ahead. Ma'am Drisya?
Yes. I'll be sharing the screen. So,
Sure, ma'am.
is it visible?
Yes, ma'am, it is
Yes.
visible.
Yeah, hi, good morning. So I'm Drishya. I'm a research scholar. I'll be presenting the paper Assessment for Construction 4.0, the practice level using fuzzy logic in the construction organization. And the paper is authored by myself and my guide, Dr. Suresh. So, why construction industry? Because that's where we have a lot of market value that is popping in. So, there is a considerable growth from 16.8 billion to 62.8 billion in another uh, a decade, not even a decade, by 2032. So, construction industry is very running in a very slow pace when it comes to adopting the digital transformation, and construction 4.0, which is in line with the industry 4.0 in the construction industry, where we talk about industry 5.0 in the construction sector, we are still at the early stages of 4.0. So it is very crucial for assessing the construction industry what is the practice level of adopting construction 4.0, because we already started adopting the construction 4.0. So instead of checking on the readiness, we are checking on the practical assessment, how practically we are incorporating construction 4.0 in the industry, so that it helps us to make the journey smoother in order to adopt construction for 5.0 in the later stages. So why we have to do in the construction industry on the construction 4.0 is the conventional industry. We have to break the barriers. We have to have a competitive advantage over the other sectors and over other industries in other countries. So we have to implement this in order to improve efficiency, productivity, utilizing the automation, data exchange, making it a smart system. We have few technologies. When I say that it's in the early stages of construction 4.0, we are adopting BIM. That's one of the tool, digitally enabled tool that is in the construction area, which falls in construction 4.0. But BIM is not just the entire digital tools, set of digital tools that helps in construction. We have a lot more other emerging technologies like IoT, digital twins, cloud computing, and all those has to be incorporated along with the BIM. So that is where we adopted this study. Why in India? Because we are conducting the study in the Indian context, because we have a lot of lagging project delays because of the resource constraint, no proper management, because it spans over a decade or a very longer duration. So there are a lot of other issues that's coming in, lack of coordinations. To an extent, this can be avoided when the platform is in a digital era. We have a transparency in data. What's happening in the industry is very visible, but that is still in the very early stages. So Indian construction industry, we have a larger employment of 70 million people, which is growing to up to 100 million people in 2030. So the growth is definitely there. The expected growth of current fiscal year is almost like 8.5 to 9%. So that's another reason for taking up the study in the industry, construction industry. So smart infrastructure, we need to demand the sustainable and energy building practices. That is definitely possible with the help of construction 4.0 and later on 5.0. So we are assessing the study. So what we are doing is we take up one industry. Currently in the study, we took one case industry. We have a group of people from the case industry for the opinion, and we have a set of experts from the industry all over India. So we analyze the importance. We narrow down the factors which is very relevant for implementation of or practicing construction 4.0 in the construction industry. So we analyze the importance of each criteria from the experts from the industry throughout the India, and we compare it with the practice of those scenarios in the construction organization. As a case organization, we took XYZ organization, which is really an MNC and currently doing really good. So why we took that? Because instead of SMEs, because MSMEs, because MSMEs are still into 3.0. They are taking on the readiness of 4.0 implementations. That's the reason we took a larger MNC industry, construction industry. So we have taken the factors across management perspective, change perspective, technological perspective, and socioeconomic perspective. We analyze that. We take the importance opinion from the experts, and we importance weights from the expert opinions, and or we take the performance weights from the employees from the case organization in order to analyze where they stand in the practice in construction 4.0. For that, we use physiologic method. And proposing this assessment framework, it's really helpful to measure the practice level of construction 4.0 in the construction industry. Right now, we take one case industry. We can, in future, we can move on to the much larger number of case industries, and we can analyze and we can generalize it. So identifying the practical criteria, we have identified major 4 enablers as discussed. We further down cut down them to the factors and to the criteria attributes and criteria and attributes. So these attributes actually go into very detailed of implementation of construction 4.0 practice level in the industry. So for this, we have designed the research questions as practice level of construction 4.0. We are measuring it with the help of enablers, criteria, and attributes that we have divided. And we check the impact of practice level of these factors in construction 4.0 implementation, which we taken from the expert opinions and the comprehensive literature review. By doing the physiologic analysis, we can narrow that into the finding in the weaker attributes, also the stronger attributes. Why we are concentrating on the weaker attributes? Because already stronger attributes, we don't have to work on that. We always have to work on the weaker attributes in order to push that to the stronger attribute and make the implementation more successful. So that's why we are focusing on the weaker attributes. So these are the basic division of attributes that we have taken in the study. So there are 27 attributes we are analyzing, which is spread across the management perspective, change perspective, technological perspective, and socioeconomics perspective, which will in detail touch upon most of the scenarios of implementing the and practicing the construction 4.0. As you can clearly see, that digitization, maintenance, aligning the resources to emerging technologies, how the automation is done, how the habitual resistance is adopted, and how the maintenance is done, huge investment, how we can utilize it in an efficient way, data management, automation, sustainability consideration on social aspect, how industry image globally will be taken into for marketing competitive advantage, frequent communication between the stakeholders, because it's very fragmented industry, the construction industry. So the frequent communication between stakeholders is another important issue. So all these criteria or attributes are narrowed down, and we have analyzed with the both the importance in the sector and also how the practice or implementation in the organization that has been done. So how we do is we collect the data from a group of experts, and we collect on evaluating on the importance of these criteria in the industry, and a group of employees from the case organization analyzing how it is practiced or implemented in that particular case organization. So we can analyze the closeness between the importance and the practice level. If it's really close, that's very and good. If it's really far away, then we have to really work upon the criteria to bring that closer. So it's much more easier for the organization to get a framework where we have to work on, so that we can closely work with the or make the implementation much more smoother. So input is gathered from the experts. Then the input has been changed to, yes.
I'm really sorry, but I'd like to remind you of the time limit.
Yeah. So linguistic scale application, then I'll just go through the case implementation by the methodology. We take the opinions from the experts and the employees. Then we finally check on the fuzzy performance importance index by aggregating all the responses that we got with the help of Euclidean distance comparison. Why Euclidean distance comparison? That helps us to check the closeness of importance and the practice of the organization. So the lower values with the FPII, that is a fuzzy performance important index, we take it as a weaker attributes where we have to work on. This is the table that we got from each and every criteria that is listed down. That is all the 27 criteria. You can clearly see there are attributes which is of higher ranking, where we concentrate on the lower ranking, which mostly comes around 2 as a value. We take it as a lower attributes. So we took 80-20 rule, and we have arrived at 5 criteria which is really lower or weaker attribute where we have to work upon. So these are the 5 criteria in that particular case organization where they lag in practice or implementation of the construction 4.0. So this can be the reason, actual reason for pulling that down to the moving on to the construction 5.0. So maintaining compatible and standardized technology among the stakeholders, because it's a fragmented industry, a lot of stakeholders has to involve and work together with the same platform. That's very difficult in this industry. Then the rapid change in technologies and their adoption. It's a long duration project usually when it comes to construction. So technologies are keep on changing. Every change that cannot be adopted because it comes with a huge investment and training to the workers into adapt it. So that's another difficulty that's finding. Maximizing transparency in the project delivery, because everything cannot be transparent in the construction industry, which is very fragmented. It can be, it makes life easier if everything isn't falling in the correct place. That's not happening actually. And increasing construction speed by process enhancement. That's another delay, because project delivery issues, mainly because of the resource issues. There is no permanent workers, or that's happening. A lot of contract workers are involved, where the contract workers, the migrant workers are coming in. Migrant workers where they don't have the proper backups or policies or incentives are provided. So there will be a lot of change in the issues, and health issues are also coming in. So increasing construction speed is another issue, and frequent communication between stakeholders. It's really important, and that's always weaker because there is no transparent platform which can connect it to the third weaker point. There is no transparent platform to bring them together. The communication is always an issue. So these are the weaker attributes that is identified. From this framework, the case organization actually adopted it, and they are working towards these. Later on in the future studies, what we are trying to do is we are expanding the study to the much more construction organization, and we check the pattern, how the trend is going on, and we can generalize on the issues, so that across India we can generalize the concept and criteria which where we have to focus on moving and practicing the construction
Okay, ma'am.
4.0.
Okay. Yeah. Thank you, ma'am.
Thank
Can you
you.
please tell me your study is in primary stage or what?
It's not primary, because I have parallel studies that is conducted. This is 4.0 practice level. There is another study that I'm conducting on 5.0 readiness level, because only once this is done, we can move on. And there is another study that I have conducted on the digital transformation of construction industry. So this is all in line with, and
Through this paper, what you are going to present?
Sorry?
Through this research paper, what you are going to convey the message?
The practice in the construction industry of 4.0, because in India, it's only in the 4.0 stage. So we are checking on the practice.
Okay, so you have mentioned the different issues which are running in the particular industry level. Okay, so what is your contribution in this research activity?
The case organization actually had a very good impact by identifying these 5 factors. So I have already informed the case organization. They can work on these 5 weaker attributes first, so that there will be a graph in the study on the closeness relation. So where they currently lie is, they are practicing in a very good standard, but extremely good, that's still yet to achieve. So if they work on these weaker attributes, they can easily reach on the extremely good implementation process of construction 4.0. So once they this working on,
have you implemented this particular issue scenario in particular industry?
That's currently implementing. So once they implement and run it successfully, we can conduct another study on the same same case organization with the same attribute and check whether it is in extremely good state.
Okay, 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 sir. Thank you, ma'am. Thank you. Good
Thank you.
study.
Thank you.
Next presenter.
Yeah, so I'd like to invite next paper presenter, Mayur Gaikwad, with the paper titled Automatic Firefighting Robot for Warehouses and Storages. So if you're ready, then you may go ahead.
Yes, ma'am, I'm ready.
Sure.
So it is visible, sir?
Yes, sir, it is visible.
Okay, so just okay. My name is Mayur Gaikwad. I'm currently graduated from Vishwakarma Institute of Technology. So our topic is automatic firefighting robot for warehouses and storages. With me, Devish Kulkarni is also there, my project mate. So we are presenting this paper on behalf of
Excuse me, sir.
college screen.
Could
Yes,
you
ma'am.
please put your presentation in full screen mode?
I have put ma'am in full screen mode.
No, no, no.
Sir,
Do one
please
thing.
start it in slideshow mode.
Yeah,
It's
slideshow. No,
I have started in slideshow mode. Maybe it is
no.
not
Click
showing.
on enable editing. Click on
Uh,
enable editing.
yes. Okay.
Go to
Yes.
slideshow menu.
Yeah. Okay.
Your screen is not
Not
visible.
visible. Okay. Okay, sir. So,
Your
good
screen is
morning,
not
all.
visible.
Why is it happening?
Please share your screen once again.
Okay, sir. I will share it once again. I will share the entire screen. So please be- Now it is visible.
yes, sir.
Ishita, ma'am, is it visible on your side?
Yes, sir. It is visible on my side. It's in
Okay,
full screen mode now.
okay, okay, okay.
Yeah.
Please go ahead.
Okay, good morning all. So our paper title is Automatic Firefighting Robot for Warehouses and Storages. So as we know that warehouses and storage facilities, we have chosen this particular topic. So they are highly vulnerable to fires due to the presence of flammable materials and high density storage layouts. So traditional fire detection and suppression systems, as we know that they frequently encounter limitations in such environments, such as closed space and compact. And in that space, very hazardous situations like delayed response times may be fatal to the situation, fire, in which a fire has taken place. So, the study describes the design and development of an automatic firefighting robot, specifically which combines advanced sensors for smoke, heat, and flame detection. So it has the capabilities to detect fire based on such as we are using IR sensor, which can detect smoke and fire. So with real-time navigation capabilities to autonomously locate fire sources. Some of them uses thermal imaging cameras, infrared sensors, and lidar technology to precisely map the environment. But we are only using right now infrared sensors to detect fires and detect obstacles and navigate the aero as well as a compact space in the warehouse and storage sections. So the robot has a multi-directional water or foam nozzle for efficient fire suppression as well as a decision-making algorithm. Uh, yeah, like so. This is the development of robots equipped with AI, advanced sensors, and autonomous applications.
Excuse me, sir.
It, yes,
I'm
ma'am.
really sorry to disturb you, but you haven't changed your slide. It's still stuck on the introduction.
Okay,
Yeah,
sorry, ma'am. Sorry.
perfect.
So yeah, now we can talk about the warehouse fire safety challenges. First is the I said like compact space very high density storage materials, and some of them may also include flammable materials. So in that space, the challenges are like that. It can spread rapidly. So first point is rapid fire spread. The fire can spread rapidly and it can be uncontrollable. Limited access is the one point. Compact space and this hazardous environments, smoke, heat, and collapsing structures make human intervention risky. So it is very impossible in such compact spaces to navigate for humans to enter and douse the fire. So and high risk of damage is also there. Extensive fire damage can lead to significant financial loss and business disruption. And now we'll talk about the limitations of current firefighting methods. First is the delayed response. We know that our traditional firefighting, like firefighters, firefighting vehicles, and all the people working for it, like majority they have the delayed response. Like when such a fire incidents occur, they usually never arrive on time. Second is the limited reach. In such compact and close surroundings, uh, uh, generally they have very limited reach to go actually inside that surrounding and extinguish the fires. So, like manual fire extinguishers and hoses may not be able to reach all the areas of the warehouse, which makes the fire in specifically warehouses and storages difficult to extinguish. And third point is risk to human life. It's always a risky situation, risky job for the firefighters to endanger their lives and extinguish the fires. So third is this limitation, and fourth is high cost of damage. Fire damage majorly leads to financial losses and loss of human life also. So these are the four main limitations of current firefighting methods. And now we are introducing the solution from our side, what we think we can do to overcome these limitations. So first is the autonomous operation. Our robot navigates and extinguishes fires without any human intervention. It's completely automatic. Once we deployed that robot, then it can detect the fire. It can autonomously navigate to it without any human intervention after that. So first is that autonomous operation, real-time monitoring. So it detects fire hazards and immediately acts according to the situation. So we have infrared sensors to detect the fire, and it immediately extinguishes the fires with the water container attached to it through the motor. So this is the real-time monitoring. Advanced sensors identifies the type and severity of fire. We have purposely designed this robot for the warehouses and storages, which have uh, what we can say, compact and close surroundings to navigate it freely. So that's we have it has only two wheels in the this and one sliding what we consider one circular wheel to navigate it easily, and also it has advanced sensors like infrared, and it it basically detects fires and autonomously navigates to it. And fourth is the precise water spray. It We have attached a pipe, so and reduces the area, so the pressure could be high, so there could be precise water flow with the right amount of pressure, not too much high, not too much low, to extinguish the fires effectively with minimum water wastage. And these are the key features and capabilities of our project. First is fire detection, as we say. Advanced sensor detect smoke, heat, and flames. Second is precise navigation, autonomous navigation system. It helps to navigate the surroundings of the closed surroundings very effectively. Third is the water suppression, powerful, precise water spray system. effectively extinguishes fires. We have specifically designed its water pipe to increase the pressure. We have reduced its area to increase the pressure so it can effectively extinguish fire without using more, what we can say, a large amount of water. And fourth is autonomously operated. As I have told that it operates autonomously without any human interaction. With the Arduino, we are using microcontroller. And this is the real world deployment scenario, like how it is gonna be working in the real world situations. First when we deployed the robot, it initial detects the fire with the sensors attached to it. In this case, IR sensors. It detects smoke and flame, and it sends a message to the what we can say to the Arduino. Then it sends the message to the motor, which then motor sprays the water through its pipe to the uh, fire surroundings. And the continual operational adaptation, the robot assesses the damage and provides data for future improvements. Uh, and we'll talk about the advantages of traditional fire suppression. First is enhanced safety. It protects human lives as no human intervention is needed after we deployed the robot. Increased efficiency. It responds faster and more efficiently to fire hazards. Like it has a very minimum reaction time. It quickly, when detects the fire, the system quickly reacts and sprays water to the. And we can also change water to other fire extinguishing materials to effectively extinguish fires on a large amount of scale. Third is the reduced damage. Precise water spray minimizes water wastage and collateral damage of human lives. And this is the cost-effective solution, as according to our prototype, our thinking that we have designed this robot to be cost-effective, so that it can be used on a now in a small scale, but we can improve it to uh, use it on a large scale. This is the implementation and integration process.
Excuse me,
Uh,
sir. I'd
yes,
like to
ma'am.
remind you of the time limit.
Yeah,
Okay,
please
ma'am.
continue.
It is
It's
only
one minute.
the final part. Like,
Sure, sir.
okay, I'll go through it quickly. Like, I have already tell you how the robot works. So let's jump to the conclusion. The autonomous firefighting robot showcased in this project, in this paper, offers a workable and effective way to identify and extinguish fire in areas, like we say, in warehouses and storages that are closed and compact surroundings, which are challenging for human studies. Through the integration of sensors, motors, servo mechanism, and from the robot is able to navigate its environment on its own, locate fire, and carry out firefighting process. So that's it. This innovation showcases the potential of robotics. Uh, Thank you, ma'am.
Okay, your study is very good actually. You're talking about the firefighting robot for warehouse and storages. So have you
Yes.
made this product or have you made some part of the product?
Yes, sir. We have actually added the all the photos of the uh, our robot in the paper, where you can see that, uh, and
Where you where you had it?
in the paper, sir.
In the paper. Okay.
Yes, we have added its paper. We have added the photos in the paper, and I've also explained that what we have done new, like we have in the traditional robots, we see four wheels, microcontroller, Arduino, and etc. Sensors, and fire, what we can say, water containers with motors to put out the fires. But here we have what done new. We have installed one circular wheel to navigate the closed and compact surroundings quickly, as with the first in the front, only one circular wheel is there. So majority the robot is running on the back wheels, and when it have to turn it, it just turns on the it can turn staying in the one position. It can move 360 degree to extinguish fires in its surroundings. And second, we
Last
have
question from my side. What are the different algorithms you have used?
so algorithms. Actually, we have used normal code in Arduino. Like we have done any new in that.
In your presentation, you have said that you have used the different types of algorithm. Can you please name it at least two algorithms?
Algorithms in the code.
In your presentation, you have used this term. You have used different algorithms for making the
Uh,
robots.
Algorithms.
So can you please name it at least two algorithms? Is it possible?
Uh, Algorithms actually I'm not getting like in the code aspect or in the designing aspect in the
Okay, fine. Okay, thank you.
okay, sir.
Thank you, sir. We'll be moving on with our next paper presenter. I'd like to invite paper presenter our co-worker Vivek with the paper titled Data-Driven Optimization of Hybrid Renewable Energy Systems, Managing Net Metering Costs Through Machine Learning. So if you're ready, then you may start with your presentation. Sir Vivek. Seems we do not have him in the meeting yet. Till then, we'll be moving on with the next paper presenter. Lokesh Khedekar with the paper titled Enhanced Feature Extraction for Phishing URL Detection, a comprehensive study of structural, host-based content, and n-gram attributes. So if you're ready, then you may start with your presentation.
Just a minute.
Sure, sir.
Please maximize it. Sir, go to slides.
Yeah, just a minute.
Slideshow.
Is it visible, sir?
Yes. Please go ahead, sir.
Is it visible, sir?
Yes.
I'm audible also?
Yes. Please go ahead.
Okay. Okay, fine. Sir, I'm Lokesh Khedekar, PhD scholar from MIT ADT University. In this study, I'm just focusing on what enhancing a feature extraction from the phishing URL detections. Now, as we know that whenever we are having an URL over there, we are trying to detecting a different features which is exist inside that URL. Like over here, I'm focusing on what three kinds of features are there, like what lexical features are there, host-based features and content-based and in-graph analysis. I'm going to identify what are the different kinds of features that we are having, which is superior or which is best for me is to identify that URL is malicious is or no. Now here is what in this study I'm discussing about what a data set, different feature extractions, proposed feature extractions, phishing URL detection system, proposed framework, and conclusion. Now I'm moving forward towards the moving forward towards the data set. Problem statement over here. In this problem statement, I'm trying to detecting what over here. I'm trying to detecting a URL, phishing URL from my phishing URL, which is exists inside a QR code over there. Now, in this study, I'm focusing on this data set. Within my data set, near about 6,32,508 URLs are there, which is like what like over here we are having 3,16,254 means near about 50% begin URL and 50% of malicious URL over there means this the data set that I have it is perfectly balanced with me. What are the different column which exist inside my data set like what over here like what URL label and result, these are the three column which exist inside my data set. the URL means like what actual web address, the strings over there. So obviously we are having inside my data set strings over there. So I'm trying to detecting the what are the features which is exist inside my URL. Okay. Now over here, as we know that whenever we are dealing with the feature extractions over here, the transferring a rate raw data that we are having into the meaningful and the relevant numerical features over there. So that as whenever we can say that what are the different now in objective one, sir, I have studied what a different scanner over there. And within that they different scanner, they are using a different detection method and feature extraction, and the different classifiers are there. Near about uh, 10 scanner I have studied and identified the some sort of the features that is exist. Now here we can say that the last one is the 35 reference. Okay, 35 scanner that we are having. Within that scanner, near about the 40 features that they have extracted, and they are applying the different machine learning algorithms for what to detecting that URL is malicious, yes or no. Then I'm trying to propose, I'm additionally added near about the 15 plus, means here we can say that, and another text-based features over there. So near about 40,000, 4,000 or 40, the based on what kinds of strings which is exist inside my URL. Depending on that, they have the retrieve the number of features over there. Why? Because of I'm adding what a text-based features also. In this study, I'm focusing on what, sir? Basically, whenever we are having, I'm trying to dealing with what are three different framework over here. I'm trying to creating a framework one for what a feature selection, lexical analysis features. I'm trying to creating a framework two for what to creating whenever I'm extracting what are the content and host features are there, and I'm trying to creating a third features for a third framework for what, and whenever I'm extracting what and text-based features from my URL. Okay, and then I'm trying to comparing, and then I'm again this framework one, framework two, and framework three we have. And after that, I'm trying to hybrid framework, that's a framework four, which is a combination of one, two, and three. And then I'm trying to creating what my own additional features I'm trying to add. This is all are the future scopes, sir. Means whenever I'm trying to detecting some features, some URL which is there is the it is malicious or not. I'm trying to identifying that properly. You will get what the malicious URL is or no. So that I'm trying to deal with what and adding the number of features so that you will get a proper accurate result from that. Okay, like over here as a basic URL, basic systems I have implemented over here, like what input URL, extracting what are the features which is exist inside my URL over there. Then what are the after that I'm transferring toward the after extracting the features means we are trying for what like what train our model, and then we are predicting for that URL is either it is malicious yes or no. And over here is again what we are trying to deal with what that the QR code we are having, and within that QR code embedded URL which is exist over there. And whenever some scanners are there, they can scan that URL and they are just predicting what that URL which is scanned by you, it is a malicious yes or no. Now, this is what basically framework over here is framework one. Within that, just time you added what over here, upload your QR code, just uploading, submitting over there, and you will get a desired output. It is basic systems I have implemented till now, sir. And now, basically means what this is what my objective do, and what I'm trying to creating what over in this study. I'm trying to studying what are the number of features we can extract from the URL which is exist. That's it, sir. Thank you.
Okay, your study is very good, sir. As per computer science is concerned, you are tracking about the phishing URL detection. So which algorithm you used in your study? Hello, am I audible? Hello, am I audible?
Yes, sir, you are audible.
Lokesh sir, are you there? Okay, might be he disconnected.
So you're audible. It seems Sir Lokesh is not able to
Yes,
hear.
yes.
He seems to have a network issue, I believe.
Yeah.
So shall we move on with the next presentation, sir?
Yes, sure.
Sure, sir. I'd like to invite our next paper presenter. We have with us Megha Mohan with the paper titled Exploring Biases and Interpretability of Deep Learning Models. Ma'am, if you're ready, then you may start with your presentation.
Yes, I'm ready. Okay. Is the screen visible?
Yes,
Yes,
ma'am,
yes.
it is visible.
Okay. Good morning. My name is Megha Mohan, a BTech student at Amrita Vishwa Vidyapeetham, Amritapuri. I would like to acknowledge my guide, Geeta ma'am, for guiding us throughout this research. These are the agendas. AI is now deeply embedded in critical areas like healthcare, hiring, finance, and criminal justice. With this rapid integration comes the responsibility to ensure that these systems behave ethically. AI ethic emphasizes 4 key values. First one is accountability, ensuring someone is responsible for AI decision. Second is transparency, making the systems working understandable. Then there is fairness, reducing bias and avoiding harm to specific groups. And the fourth last one is explainability and interpretability, making sure people can interpret how decisions are made and how inputs affect outcomes. One of the most pressing ethical concern is bias. If left unchecked, AI can reinforce historical discrimination, often in suitable but harmful ways. A major A major motive behind this project is the tendency of AI models to learn bias patterns from data, even if not explicitly trained to do so. So let's take a compass algorithm for an example. It was used to assess the risk of reoffending in the US criminal justice system. Studies showed it gave higher risk score to the Black individual compared to the white individual, even when their records were similar. This wasn't because the Black offender were more dangerous, but because historical data was skewed, reflecting a large ratio of Black arrest. This kind of real world harm motivated us to act proactively. Our paper sets 4 clear objectives. First one is bias detection. We will identify the bias in real time while the model is still training. Then next is the dynamic adjustment, automatically reweight training based on detected bias. Then there is interpretability. We use a grade cam to visualize and see where the model is focusing. And the last one is the fairness evaluation. Measure how the model's fairness improves across demographic groups. The key problem we address is the most bias mitigation happen after training, often with limited transparency or interpretability. Our contribution is to bring bias detection and correction in the training loop itself. So we have combined grade cam, which helps visualize which part the input the model is focusing on, with the dynamic reweighing algorithm. This algorithm adjusts the model's learning focus in real time, encouraging it to prioritize unbiased and meaningful features. So this work bridges the gap between the post hoc fairness technique and the need for real-time explainable bias mitigation, moving us toward fairer and more transparent AI. So the data set we have used is the UTK face data set. It has over like 20,000 images, and the image is formatted. The file name is formatted in a way which is age underscore gender underscore race underscore data and time. The age is from 0 to 116. Gender is of female and male. And the race is of 5 types, which is white, black, Asian, Indian, and others. So coming to our proposed system, we have used our UTK phase data set, and then it is trained using a ResNet model. This ResNet is a pre-trained ResNet 18 model, and we have modified the fully connected layer, and the bottleneck layer is also added in it. And then we have to know where this model is focusing on. So for that, we have used a explainable AI gradecam tool. In that, we will get to know, like, there will be a red color where the model is focusing on. And then we have ground truth. Ground truth we will be taking as the facial features, and we will be producing a bounding box around it. And then we will be producing a bounding box around the red region where the gradecam is showing, where the model is focusing on. And then we will find out the IOU, so that we get to know whether the model is in the ground truth area or it is deviating from it. So after getting the IOU value, we will be doing a basic reweighing, which is 1 minus IOU score. With that, we will get a weight, and then that is applied to a loss function. And then the feedback loop comes again to the ResNet, and ResNet will learn. That's how we are evaluating the model. The results in the initial training is shown like this, how the gender and race is predicted. As you can see, this area, we can see the truth label and the predictor label, how much it's predicted, and in the female case, how much is predicted correctly. And in the same case, the race matrix also shows diagonally, we will know which is predicted correctly, and the others are predicted like in a wrong way. Like if it is race 0, it is predicted race 1, like that. And then we have this demographic parity. With this, we will this is a fairness matrix, and we will know how much it is fairness is shown in it, like how much importance is given. So we can see, like in the female, in the demographic parity, it means if it is 0, near to 0, means it is perfect, and if it is 1, then it's biased. So we can see the female is like 0.0 to 1. So we'll get to know the more priority is given to the female here. And when it comes to the race part, the more biased is the race 1, and more fairest is the race 2. So these are the results we got initially before the reweighing is done. And this is after reweighing. So before reweighing, you can see how the score is with just ResNet. And after reweighing is done and with the feedback loop, we get to know that there is better performance in the model. This is the images. This is the original heat map before reweighing, and this is after reweighing. So we have given the facial region, which is the nose and the upper lip, as the feature ground truth label. That's why it's here. So coming to the conclusion, our work presents a novel dynamic bias mitigation approach for multitask model by combining the gradecam based interpretability with IOU guided reweighing in a real-time feedback loop. This integration allows the model to actively adjust in learning focus, improving both performance and fairness during training, not just after. So the innovation lies in how these components work together to detect, interpret, and correct bias as it emerges. So, however, this approach has limitation, like it currently addresses only the gender and race bias, and it is affected by the bias present in the training data set itself, and adds a computational overhead. So, in the future work, we will try to explore more bias type and then optimize the efficiency and test across more diverse data set to ensure broader applicability. So this method is a step forward to building more accountable, explainable, and equitable AI system. Thank you. These are the acknowledgement and the reference we have used. Thank you.
Okay, fine, Megha. Your study is very good and related to machine learning.
Yes, sir.
Uh, Related to machine learning and deep learning, है ना?
Yes,
So,
sir.
can you please tell me how you are going to explore the biasness through AI?
Biasness. Okay. In this, the issue is with the data set. So in our case, the male and female ratio is different. It should actually be equal so that the model can perform in a correct way. So we are making it into the correct ratio, avoiding the biases in it. And when it comes to race also, we are telling it to focus with the reweighing, that it should be focusing on like the biased region, so that we can detect the bias and mitigate it.
For calculating the ratio, is there any unit in your
Uh,
study?
Ratio, no, there is, like, if how much ever the female is less in this, so how much ever is there, we will take that much amount itself for the male, because
And from
males is higher.
yeah, yeah. And from where you pick these data sets?
Data set, Kaggle, it is a platform, open source platform.
Okay, fine. So you are doing PhD or what?
No, I'm a BTech student, sir.
Students. So
Yes, sir.
you're doing very good research. Yeah, it
Thank
is.
you, sir.
Thank you.
Pardon, sir, I didn't hear you.
Yeah, it is appreciable. So have you
Okay.
made a model based on the deep learning?
Yes, sir. That was our next step. We have already made another deep learning model integrated, and we'll be publishing a journal soon. We have to submit it.
Okay, fine.
Okay.
Okay, okay.
Okay.
Thank you.
Thank you, sir.
Thank you, sir. Thank you, ma'am. We will be proceeding with our next paper presenter. I'd like to invite paper presenter Swati Nikam with the paper titled Homomorphic Encryption for Privacy Preservation. Ma'am, if you're ready, then you may go ahead with the presentation. Ma'am Swati.
Yes, I'm here. Thank you. Is it visible?
Yes.
Yes, ma'am, it is visible.
Okay. Good morning, sir. Okay, so this is Swati. I'm here to present my paper for homomorphic encryption for privacy preservation. My research supervisor is Dr. Kulkarni. She's from MIT ADT University, and my supervisor, come friend, is Amrita Manjrekar from Shivaji University, Kolhapur. So here we start. As I say, sir, this is just a tip of iceberg, homomorphic encryption for privacy preservation. So here we are. Mhm. The first thing is, like, I'd like to introduce about this topic, homomorphic encryption, motivation, survey towards it, approaches, and conclusion. Okay. So as we say, security. Security is the main concern right now. Wherever we are going, everything like AI, ML, everything concerns with security. So like all the very personal or sensitive information can be shared through these clouds. And what we need to do is, like, how we can stop this, or how we can overcome these breaches is what we will be studying to, will go through this. So background, just like everyone knows what is encryption. Most of the people, sorry, most of us know about encryption. Like traditional encryption process includes key generation, encryption, decryption as we go along. And we distribute the key over, the keys are distributed so that the decryption takes place over the cloud. So we'll come to motivation. What is motivating all over the world to go for this homomorphic encryption? So homomorphic encryption, it is
the way that we encrypt the data, and without decryption, the other party is or the third party is able to process the data. So that is what the encryption, like homomorphic encryption is. I'll just give the full description. The homomorphic encryption is a form of encryption that allows the computation to be performed on encrypted data without first having to decrypt it. As our traditional method, what we have is like for encryption and encryption, we need to have key generations, or we need to pass on the key, we need to decrypt the data. But homomorphic encryption is trying to create a world where no decryption will be done, and all the computations which are performed on the encrypted data itself. So how it is done? So like first we'll go through how the encryption and decryption, which is the tradition, which is the method which is going on right now. We'll just discuss about it. So what happens is like we have plain text, we have public key and private key. The encryption takes place by a ciphertext, and the encryption happens, and the decryption, like all the we have encryption and decryption. What happens in homomorphic encryption? As we said, homomorphic encryption is something where we do not decrypt the data. So that is how this is done. So this is done with the help of evaluation. We evaluate some things on encrypted data itself, and through which we get the data, which is like an original message. So like we have this is the equation for SIM, and this is the philosophy. Like when we have data, it is encrypted. With the homomorphic encryption, we encrypt the data. So even though it goes on the cloud, the data remains encrypted itself. And when the client needs it back again, it is decrypted with the homomorphic encryption itself, and the decrypted results are been shown to the client. Okay. So what are the things we used for this? Main thing is like for homomorphic encryption, all the data is like evaluations are done on the encrypted data itself. So there are methods through which the evaluation is done. Like like for example, the computational models used are Boolean, modular arithmetic, and floating point. For Boolean, this model, it's good for number comparison, which was very if we say the history of homomorphic encryption, which we will go through. So number comparison was the first one, and then we came for the integer arithmetic scalar multiplication and polynomial approximation, which where we are able to do the evaluation on the machine learning models also. These are some of the schemes which are used. We'll come to that in later part. So this is how the literature survey, how the things are like Gentry 2009. He was the first one to establish this something called as homomorphic encryption, which was a fantasy that time. So after that, like the evaluation has been so much that right now most of the applications are going for homomorphic encryption. And as you can see, this is a development, but for everyone, the base has been Gentry, which was done in like 2009. So this is what our schemes are, that how it progressed. In 2009, Craig Gentry had laid the first philosophy of homomorphic encryption, where we can do the evaluation on the encrypted data only, and the recipient will receive the results as they were for the encrypted data. So this is the problem. Like this was a problem, like lattice-based cryptography, and which was used to refresh the noise. And in 2011, another person associated with Gentry and formed the next one. So these are some of the basic schemes which are used in homomorphic encryption. This is the distribution for homomorphic encryption, which has been started like since last 50 years, people are doing work on that. but the fruitfulness we can see it right now. So the homomorphic encryption can be like partitioned as first it was only partial homomorphic encryption. It is somewhat homomorphic encryption, and the later is fully homomorphic encryption. So how is partial homomorphic encryption? Partial homomorphic encryption was something where only we were able to do additions for the evaluation. For the evaluating part, we were only able to do the additions, while the next partial homomorphic encryption is like wherein we were able to do the multiplications. In somewhat homomorphic encryption, major part was used for this lattice based it was, and later fully homomorphic encryption. Like fully homomorphic encryption is such a thing which has been developed since 2011. It has been developed in such a way that um, all the evaluation, all the backside evaluation is being done with full encryption. Okay. So this is how the schemes, like whatever schemes we discussed earlier. So these are how the things are. Like in partial homomorphic encryption, we are able to do only addition or multiplication, but we are not able to do both. And the schemes associated which are the traditional use RSA and LGAML. Somewhat homomorphic encryption is somewhere where there are limited operations we can perform on description, and BGP scheme is useful for that. Right now, the full accommodation is with fully homomorphic encryption, where it supports all the computation, encrypted computations, as well as it is going along with machine learning and deep learning also. And the schemes supporting those are BFE, CKKS, and TFHE. We'll discuss about these schemes also later. So these are the schemes which we were talking about. These are the major schemes which are been in use for the homomorphic encryption. So this is BFV, BGV, CKKS, TFHE. These have been evolved in last 10 years. The major thing is like the names are been given after the people who have invented it, most of the people. So like it's difficult to pronounce. What are the data types used? Like BFV is there. So as we said earlier, the data type used is integers, and operations, mostly evaluations used are addition and multiplication. The precision is very quite well, and the use cases, like what exactly they are used for, it is used for voting and private aggregation. And the libraries, as said in my paper, that whatever libraries they are using, like Microsoft Seal and Palisade is the one who are using this scheme. But these schemes form the basis of homomorphic encryption. The same way BJV, major is the like libraries which we are depending on for the schemes are Halep, Microsoft Seal, Tensile, and Concrete Zama.
Excuse me, ma'am.
Yes, ma'am.
I'm really sorry to disturb you, but I'd like to remind you of the time limit.
Yes, sure. So this is a timeline for homomorphic encryption, where it has been evolved in such a way that we can say it from 1978 to 2020. These are the libraries which are associated with homomorphic encryption, and these are the use cases. Like for example, right now we have going on like file encryption and secure emails. These are using AES and RSA, but for secure cloud homomorphic or for voting system, we can use the homomorphic encryption. These are the growing applications for homomorphic encryption. Healthcare, finance, AI, ML, everywhere, mostly in another 10 to 15 years, homomorphic encryption will come into existence. This is the conclusion, like how the homomorphic encryption can be used for healthcare. That's it, sir. This is my part of research subject now.
Swati ma'am, are you going to do PhD?
Yes, sir. I'm doing the PhD.
Is it PhD topic?
Yes, sir. This is the PhD topic, but as I said, today's topic is just a tip of the iceberg. This is just an introduction to the homomorphic encryption.
Back. Go back,
Yes.
back, back. Okay. Now I'm having a question. You have find out the libraries over here like OpenFSE, Spark, Pencil, है ना? So
Yes, sir.
you have taken these libraries in your
Yes, sir.
these libraries for your study.
Yes, sir. These libraries were taken for the initial studies, but right now I'm working for homomorphic encryption in deep learning. So
So
from
you
the libraries which are given, I'm fully focusing on Tensile, which is used for machine learning and deep learning.
it's not Pencil library, right?
What, sir?
Using Python.
Yes, sir.
You are using Pencil using Python, right?
Yes, sir.
Okay. So and it is developed by Microsoft, so it is freely available on net.
Yes, sir. It is freely available. It's a open source, so it is freely available.
And what do you mean by MIT? Developed by MIT, first one.
Yes, the first one, OpenFHE, is developed by the University MIT, where only arithmetic integers were used, and the language used was C++.
Okay, so which algorithm you are used for the homomorphic encryption in your
So right now, see how we are trying to do is like I'm trying to do healthcare. How to use home like can I come to the last one? Yeah. So this is the system architecture for our letter system. So in this, we are trying to take the this PHR, the patient's data, and that there we are applying the homomorphic encryption. So
where
there are
you
like two. Yes, sir.
from where you are going to collect the patient data.
The data will be from Kaggle or somewhere because I'm right now we are concentrating. See, that's what there are like. If we see, we have like two types of data. Like there is something called as the numerical data and the image data, and both data can be used in PHR. So right now I'm only concentrating on the image data. How image data can be used in through deep learning and homomorphic encryption.
You are going to collect the data from the Kaggle.
Yes. Kaggle means I'll shift to one more slide if possible.
Just wait. Are you not visiting to any hospital? Like you can get the live data or live image.
Yes, sir. But right now, how we are doing, like this is in a very initial phase. So first, I am trying to implement the data. Means exactly it has to be implemented. The encryption and like what we are saying, see on the through on the images. If the same thing is done with like 100 images or whatever the initial data I am having, then we can go for the real time data
Okay, fine.
and it will be successful. Like it's better to try on the first on the trials.
Okay. So it is primary study.
Yes, I'll show you how the diagram for the next one.
No need, ma'am. Thank you very much.
Yeah. Yes. Thank you, sir. Thank you very much.
Thank you, sir. Thank you, ma'am. We'll be proceeding on with our next paper presenter. I'd like to invite paper presenter Moonal Vibhuti with the paper titled Interpretable Fake News Detection Using Neural Networks and Line. Ma'am, if you're ready, then you may start with your paper presentation. Ma'am Moonal.
Hello.
Yeah.
Yeah. Is my screen visible?
Ma'am, yeah, it is visible.
Yeah. Okay. I'll just put it in the slideshow mode. Yeah. So hello everyone. I am Ronal Vibhute from Cummins College of Engineering, and glad I'm here to present my paper in the ICT4SD conference, and it is called Interpretable Fake News Detection Using Neural Network and an Explainable AI, which is Line. And I would like to thank my mentor, Professor Anjali Naik, who guided me through this process. moving on, I'll be covering why is it important to identify fake news? What was my motivation? Then what were the previous works done, and what has been newly implemented by us? Then about the data set processing, etc. Then implementation, how exactly explainable AI is put into the testing pipeline, and then some results and analysis and some conclusions. So starting with introduction, why to detect fake news? So first important reason is that due to the wide usage of the social media, uh, yeah. So due to the widespread of social media, everyone is using it. So the fake news is spreading too quickly. Hence, this is the first reason. And second reason is that due to the fake news, it has impact on various fields like political decisions or stock market trends, and the public perception changes really quickly when any news is spread through these platforms. So it is necessary that we implement some measure to detect the news if it's fake or not, and then take decisions based on it. So what currently we are doing is we are collecting data from different social media platforms like Twitter, X, LinkedIn, Facebook, etc. And then we are putting it into a deep learning model, and then that deep learning model is telling whether it's a truth, fact, or is it a fake. But what happens is we do not know how these deep learning techniques work, because it is just numbers, and we cannot truly tell that uh, whether the model is like biased, or whether there are variations, etc. And even if we are able to tell that, the numbers are not really useful when other people are uh, like when other people are trying to predict trust the AI. So this is the objective, that to integrate an explainable AI line so that we know how the deep learning technique actually works. As for the related works, people have tested traditional machine learning techniques like different classifiers, different regress, logistic regression, etc. models, and they have got accuracy like 75 to 92%. They are reliable, but again, as I said, it has limited interpretability. Then people have done ensembles of classifiers and word embeddings, and they have very strong accuracy. Then there are transformer-based models, BERT, Alberta, Robert, etc. And then there is CNN plus LSTM architecture, which has some really high accuracy. Then there are graph-based models and attention mechanisms. It uses network structures, but again, the explainability was not shown in these papers. And then there are papers which have explainable artificial intelligence, like explainable AI techniques, and they just talk about it, but they don't actually give a proper kind of um, um, a summary, like the model used, the explainable AI, and what were its conclusions. So these were the gaps that the studies didn't compare the accuracy and interpretability, and then they just used different explainable AI tools or different kind of machine learning models. But and then the graph-based models are really less explored as per my findings. So we're trying to address these gaps. What we do is basically there are three main models and two other models. The fully connected neural network, the convolutional neural network, and the graph convolutional network. and then we are testing, we are giving it a text-based database, and then we're like using the same data set throughout these models, and then we are evaluating its metrics. And then we are using an explainable AI tool called Lime, and it basically assesses the interpretability, like how which word the model is focusing more to tell whether the news is fake or real. And then we are giving like a trade-off between the predictive accuracy and the explainability. Uh, Moving on, on the Kaggle, there is a data set called Wellfake, and it has over 72,000 data records. It has these number of columns, and the genre is of news. So all the news, for example, if there is some political news or some movie news. So only 3 to 4 genres were included in this data. And then whether uh, so the challenges in the data set were the noise present inside the data, and if the data set was mislabeled, like using sarcasm or satire used. So this data set is very famous. And then at the end, we have like use the title, the news context, and then the label, whether it is real or fake. First model that we have is fully connected neural network, and it uses IDF vectorization. It serves as a baseline model, and it is computationally efficient, but it ignores word orders. The next model that we have is a convolutional neural network using 1D convolutional like the architecture, and then it generalizes and it is suitable for short to medium length, and it captures local and gram patterns and give good generalization. Next, we have the graph convolutional network. It transforms the corpus of the data into a word coherence graph. And this model excels in capturing the structural relationships, and this model was complex. Then we have the LSTM with the attention layers, and the training was computationally very expensive for this model. And this attention layer in the LSTM, it helps identify which part of the text the model is focusing on. And then there is this fast text. It is a lightweight model developed by Facebook AI, and it uses average subword embeddings to generate very quick predictions. It is highly accurate, but it lacks interpretability because it is a really shallow network. The implementation is such that we first give the text data set, and then train and test it with these 5 models mentioned here. And then we note the accuracy of each model, and then we give it a sample text, and then the Lime is able to like tell on which word has the model exactly focused to give the prediction which whether it is true or false. Yeah, this is a short working on how the Lime works. It takes the data set, it takes the model, and then it takes in the trained model, and then it takes a sample model, and then it uses another smaller model and record how the predictions are changing, and based on that it shows or it explains to the user that how exactly the deep learning model worked. So it is like the interpretability. As for the result analysis, the fully connected neural network had like 96 accuracy. The CNN had 97%. Attention-based LSTM had 97 again. Fast text gave 98, which is a really high. And the graph convolutional gave only 90%. Um, so for instance, we had given after training of the models, we had given this news, which is a real news to the different models of graph convolutional network and convolutional neural networks. And then we these pasted outputs are after we'll give the sample text to the Lime interpreter. And then we see that in the graph convolutional neural network in the left side, that it
Excuse me,
focuses
ma'am.
on words.
I'm really sorry to disturb you, but I'd like to remind you of the time limit.
Yeah, I'm just finishing. It's the last part. So continuing, it focused on the words like it's, and, new, etc., and really general words in the sentences. So it is more syntactical. And then the CNN gave it gave focus to more nouns and pronouns and verbs. So here we can see the difference. Uh, Here is a table showing which model gave how much interpretability. Uh, yeah, and to conclude, I have these that FastText gave highest accuracy, GCN was less accurate, but it gave um, uh, a richer and more distributed explanations. Like truth is 60% and false, whether it is false is 40%, like that. And then the CNN, it offers a middle ground with higher accuracy and partial interpretable outputs. Future work is to explore more generalized XAI tools, explainable AI tools, and then we test on diverse data sets of different languages and genres, and explore the trade-off more between interpretability and accuracy.
Okay, Mrunal ma'am,
Yeah. Yes.
just one from my side.
Yeah.
You're a student or PhD scholar?
No, I am a student, recently graduated.
Recently graduated. Okay. So your research paper based on the fake news detection using neural network, right?
Yes,
So
sir.
what you have made very good presentation. You have made, I think you have made very good research paper also. You have mentioned the accuracy rate also. Now
Yes,
just
sir.
to ask one question, which parameters you have considered for the neural network for the data set?
So parameters, as in I gave it the title as well as the content, the actual news. I could have used different numerical parameters like the length or like the number of nouns or pronouns into it, but I kept it like general base, like a baseline kind of parameters, like just the title and the content, the news content.
You have talked about the data set,
Yes,
right?
sir.
So for the data set, which parameters you have considered so that you will get the accurate result?
I just told you the title and the content, and then I just use the targeted like, is it fake or is it real? So the based on the entire news and the target, I have like trained the models.
Which parameters are responsible for the accuracy rate? जो आपने accuracy rate दिखाया हुआ है आपके conclusion में, which parameters you have considered for the accuracy rate?
Sir, it is just like trained it on 70% data and tested on 30% data. Just that.
Go back,
Yeah, okay.
go back. Okay, ये जो 98.23, no, go to conclusion.
Okay, this one?
Go to conclusion. Conclusion, 98%.
Yeah. Highest accuracy achieved. Yeah.
Highest accuracy, 98.23, 19.19. So how
Yeah.
you achieved this?
It's just gave like a part of data set which is not trained to the models, and then just did accuracy matrix, like the predicted and the actual.
Thank you very much. Thank you. Thank you.
Thank you, sir.
Thank you, sir. Thank you, ma'am. We're proceeding on with our next paper presenter. I'd like to invite paper presenter Anmol Afre with the paper titled OCU Explain, an explainable AI approach for multi-class ocular disease detection. Ma'am, if you're ready, then you may start with your presentation. Ma'am Anmol? Yeah. Ma'am, you're on mute, I believe.
Yeah, am I audible?
Yes, ma'am, you're audible.
Okay. Okay, good morning. I am Anmol Afre, and today I am honored to present our research work, Sustainable AI approach, multi-class ocular disease detection. So this research was conducted under the valuable mentorship of Professor Dr. Nirali Nanavati and in collaboration with my co-authors Manan Parekh, Parth Patel, and Vaidehi Lad from SCED College. So let's understand the motive behind this research. So ocular diseases refer to wide range of conditions affecting the eyes, like cataract, glaucoma, AMD. So if undiagnosed, it may lead to vision impairment or even blindness. So according to World Health Organization reports, approximately 2.2 billion people across the world suffer from some form of vision impairment, and over 1 billion of these cases could have been prevented with timely diagnosis. However, many diseases are very time consuming, complex, and subjective, and it depends highly on the skills of the ophthalmologist. So, our goal was to build an automated, accurate, and explainable solution. So, our proposed solution addresses these key challenges through a multi-stage deep learning pipeline that focuses on three key objectives. The first is to enhance the retinal fundus images for clearer analysis. The second is to handle the class imbalance using data augmentation, data merging. Then finally, ensuring transparency in prediction through explainable AI using GradCam. So we reviewed several existing research papers, as you can see on the screen. Most of them achieved good performance, but many of them were limited to binary classification or they lacked explainability. So this highlighted the need for more comprehensive and interpretable multi-class approach, which led us to the development of OcuExplain. So unlike these prior models that we are seeing on the screen, our model OcuExplain classifies the fundus images into 7 distinct classes with a strong focus on both accuracy and explainability, making it very well suited for real world deployment. So creating a consolidated data set of 10,449 images was a crucial step in our project. So to achieve this, we integrated the data from 5 publicly available data sets that are mainly ARMD curated data set, eye disease classification data set, Mendeli eye disease image data set, hypertension and hypertensive retinopathy data set, and ODIR 2019 data set. So this diverse data set enabled effective training and better generalization across all the 7 classes. To support future research, this consolidated data set of 10,449 images is publicly available on Kaggle. Now, looking at the pre-processing steps, the first one was the region of interest extraction to remove the black backgrounds. So we did that by binary thresholding and contours detection. The second was noise reduction using morphological operations to enhance the image clarity and reduce the low contrast noise. The third was image enhancement to boost the contrast and highlight the details in the image. then resizing and normalizing the image to 512 cross 512 input size. Now, to address this class imbalance, especially in classes like myopia and hypertensive retinopathy, we experimented with many data augmentation techniques such as flipping, rotation, brightness, saturation, and hue adjustments. This helped us improve both robustness and reduced overfitting in underrepresented classes. Now, for classification, we experimented with 4 state-of-the-art deep learning models, which were DenseNet 201, VIT16B, EfficientNet B4, and ConNext, the last of which delivered us the best results. ConNext stands out as a modern convolutional architecture that combines the strengths of traditional CNN with transformer-inspired design principles. So why did we choose ConNext? It starts with 4x4 convolution for patch embedding, and its hierarchical architecture allows it to learn both local and global features effectively. So we applied transfer learning and gradual unfreezing of layers in the ConNext architecture, which preserved the low-level features while adapting to high-level retinal disease classification. So this boosted both accuracy and training efficiency. Now, one of the most important aspects of our work is explainability. Explainable AI refers to techniques that helps us to understand how and why an AI model makes specific decisions. As we all know, it is a critical factor in healthcare of trust and transparency. So to make our model more explainable, we use GradCam, which is a explainable AI technique that generates heat maps showing that which regions in the fundus image influence the model's prediction. So in age-related macular degeneration, the original image showed the central retina like drusen or pigment changes around the macular region. And the GradCam also highlighted the same region, that is the macular region. In cataract, the original image appears somewhat blur, and GradCam also highlighted the central area, that is the blur region. In glaucoma, the optic disc appears enlarged, and the GradCam also focused the area around the optic disc. In myopia, the retina shows strong thinning, which is common in high myopia. And GradCam also focuses on area of degeneration. In hypertensive retinopathy, the blood vessels show narrowing or irregularity, which is due to high blood pressure. And the activation in the GradCam image also highlights the region around the vessels. In diabetic retinopathy, the original image shows the yellow spots, as you can see in the image, and the GradCam also highlighted the damaged retinal area. And in the normal class, the GradCam showed even activation, which indicates absence of anomalies. So this alignment between the heat maps and the clinical literature proves that our model is not only accurate, but also clinically trustworthy and interpretable, making it suitable for real-world deployment. Now, talking about the results, among all the models that we tested, ConNext achieved the highest accuracy of 94.14% and an AUC ROC curve of 99.37%. It also outperformed DenseNet 201, VIT16B, and EfficientNet B4 in precision, recall, and F1 score. So visualizations of per class accuracy, confusion metrics, and ROC curves confirm the model's strong consistency and generalization across all the 7 classes. So concluding, our model OcuExplain is a robust, accurate, and explainable solution for multi-class ocular disease detection. Also, by combining deep learning and artificial intelligence, we bridge the gap between AI performance and clinical trust. So our model stands out by accurately classifying the fundus images into 7 distinct classes, going beyond most of the models that focus only on binary or limited class classification. So by combining Connext and GradCam, we ensure both high accuracy and explainability, making the system reliable and transparent for clinical use. This dual focus on performance and interpretability makes our model particularly suitable for real-world healthcare settings where black box models are oftenly not accepted. So overall, the model demonstrates strong potential as a clinical decision support tool, helping the ophthalmologist make informed, explainable, and faster diagnosis. In future work, adding textual explanations alongside the GradCam visuals can be done. Also, aiming in detection of multiple diseases in a single image can be done. So here are all the scholarly resources and the prior works we consulted to build and validate our study. So thank you for your attention. We hope that our work contributes meaningfully to the intersection of AI and healthcare, and we would be very happy to answer your questions.
Thank you. Thank you. Your study is very good. Just common question, which parameters you have?
Sorry, sir.
Which parameters you have used? Go to the conclusion section. Okay. So for AI performance and explainability, XAI, which parameters you have used for accuracy rate?
We used a combined data set which consisted of the images of all the 7 classes, and the data set was labeled. So we used that data set to get this accuracy.
Labeled means in which term?
Like if the image is of cataract, then along with the image was labeled as cataract.
Okay. What are the limitations in your research study?
Okay, limitations involve that we have not yet explored textual explanations like for the GradCam images, and also our model cannot classify multiple diseases in one image.
Okay. So have you made any module?
No, we have used pre-trained model, that is Connext model.
Okay. Okay, fine. Thank you.
Thank you, sir.
Thank you, sir. Thank you, ma'am. We'll be proceeding on with the next paper presenter. I'd like to invite paper presenter Vinod Kumar Minchala with the paper titled Relay Assistant Framework for MMM-BABE, a 5G NRBS system in V2X communications. Sir, if you're ready, then you may start with your presentation.
Yeah, I'm ready. Good morning, everyone. I'm Dr. Vinod, Associate Professor and Research Coordinator. Just give me a moment, we'll share the screen. Are you able to see the screen? See my presentation?
Yes, sir, it is visible.
Yeah, thank you. So our topic is relay-assisted framework for millimeter wave base station systems which is working on 5G NR for V2X application. So myself, Dr. Vinod, and along with my team, Mr. Sharat Chand and Dr. Supraja Reddy, we have been attending this session. Next slide. So the presentation outline is today we'll be discussing about the abstract introduction along with the millimeter wave and MIMO relation, and we'll show you the simulation framework what we developed and what is the need for relay along with conclusion and differences. We will end the presentation. Next. So this paper mainly investigates the characteristics of 5G NR communication. So when we are talking about a 5G NR base station system, here what is the need for relay that we have done with the thorough analysis. So first we have started a detailed analysis taking up millimeter wave base station deployment using a MIMO antenna array. So here in India we have N258 band frequency which is supposed to be there as millimeter wave band, which works at a frequency of 26 GHz. So in that band, we have simulated entire scenario using the 3GPP technical specifications. And for the simulation framework, we have taken our nearby scenario of Hyderabad ORR scenario, where we have 4 different lanes, 2 lanes with 120 kmph speed and other 2 lanes with 80 kmph speed. So as per 3GPP specifications, we have developed a Pygame module where we will simulate and show the analysis of this. And the main aspect relates with line of sight and non-line of sight vehicles. When we could see this, the basic disadvantage of this millimeter wave is it's of very short range. So, but we could able to boost with higher data rates. So when we have line of sight users, we could able to get a very good reasonable data rate could be supported. And when we want to extend this for semi-autonomous or autonomous kind of vehicular environments, it's very much important for us to those vehicles which are not under direct line of sight of the base station. So when we have this such a non-line of sight users, the need and necessity of the relay and how it could improve, that we have done the analysis and we have presented work in the paper. So it mainly shows the relay-based architecture, 2 algorithms what we developed that we are going to present. Next slide. So as you could see, when we talk about millimeter wave and MIMO, as what you could see is as the frequency increases from centimeter waves to millimeter wave, as we speak about 3G, 4G, and 5G, we could see 3G up to 4G, the frequencies of operations were megahertz, or we can say for frequency of 2.4 and 5 gigahertz. When we speak about millimeter wave, we could see frequency is increasing to almost like 26 gigahertz. Increases with this relation, we could see path loss is directly proportional to frequency. So frequency has increased in the frequency. What we can do is we could use the directional antennas for a millimeter wave operation. There's a requirement of MIMO antennas. So we require many antennas at the transmitter and receiver. That was the term MIMO itself states that we require multiple antennas at the transmitter and multiple antennas at the receiver. So here we have taken a uniform planar array as per the 3GPP specs, and you could see different base station sizes of antenna sizes we have taken, user equipment, different dimensions we have taken. NT cross NR represents the total number of antennas at the transmitter side and the receiver side. So we are talking about a downlink scenario from the base station to the user equipment, where base station may vary having an antennas from 2 cross 2 antennas to 8 cross 8 antennas, where user equipment can be a mobile phone, pedestrian, or maybe a vehicle, or any other element which receives the base station signal is having a 2 cross 2 antenna functions. Here array factors also we have calculated based on certain azimuthal angles which were specified by as per 3GPP. We calculated its linear phase shift and other values, so based on which we can get the angular dispersion values like angle of arrival and angle of departure from the base station to the user equipment. Next slide. So what we could observe with this antenna parameters, we could see the antenna size as it vary from 4, like 2 cross 2 I said, and 8 cross 8. 2 cross 2 means we are using 4 antenna elements. If I say 6 antenna elements, the dimension can be 2 cross 3. Means we have a array, as I said, uniform planar array. We can have 2 elements in x-axis and 3 antenna elements in y-axis. So, or 3 antenna elements in x-axis and y-axis. We could see different types of bit rates and best beam index rates. So bit rate suggests that when we are using 4 antenna elements, we are getting a data rate of 1 Gbps. When we are using this 8 cross 8 of 64 antenna elements at the base station, we could boost it up to 4 times of 4.225 Gbps of data rate. So it's clearly evident that MIMO is a crucial part which is required for a millimeter wave scenario. And coming to the directivity, this shows about the gain and bit rate, how we have improved. And in next slide, what we could see in the next slide is here you could see the left side scenario. We are showing the position of the user equipment, and base station is referred to a position at 0, 0, 0, and UE is at 4, 2, 4. Based on this position of the user equipment, here user equipment can be anything, can be a pedestrian, can be a car, can be a UAV. With this antenna dimension of 2 cross 2, we could see our signal is not reaching to the user equipment. The maximum directivity we could gain only with this. But same system with the different antenna dimensions of 8 cross 8, we could see the beam is is narrow. Now, when beam is narrow, you could see the directivity and high gain pattern which is going across the user equipment. That is the result which is boosting up the data rate 4 times more, and even user at longer distance can also be communicated. So that is one advantage which could be gained by using this beam pattern analysis. So this is one simulation analysis what we carried out. Next slide. So for our simulation framework, we consider a 4-lane ORR with a service road of Hyderabad at Gachibowli, near to our college at the Narsingi, where we use the OpenStreetMap to simulate the scenario using Pygame. So the simulation environment was done by using a Pygame library, where we have different types of vehicles, which you could see, which was mentioned by 3GPP technical specification sheet of 37.885 version 15.3.2, where the car length, width, and height of the car, and antenna height where it is placed, about small car, big car, and truck car, being given by this 3GPP document. So this is all over the world will be following this same specification document to develop the synthetic data. Whereas we could right side we could see the other parameters as what we have taken. The total number of transmitting antennas are 8, receiving antennas are 4, frequency of 28 gigahertz, bandwidth of 100 megahertz, transmitted power of 44 dBm, and a maximum antenna gain of 8 dBi, and height of base station is 10 meters. Taking these parameters, we could able to apply our algorithm. I'll show the algorithm there. So this is the simulation framework what we considered. Next, we have the algorithm. So we could see this as the algorithm where our input, the position of the user equipment is defined, frequency and other parameters are defined, and we calculated some values like what is the distance at which the UE is placed, what angle we could reach the UE, azimuthal and elevation angle. Then we use some DFT codebook for the MIMO, based on which the channel characteristics are performed, and we get the channel metrics, and also we need to tell about what type of path we are using, what is the path gain and path phases. Then all angular components which I defined in the previous previous slide equations were used to find out H. Once we get the H, that will be computed, giving it to the code book, and we'll be getting this best beam index, which could be substituted in order to calculate the bit rate. So this is the procedure. This is an algorithm what we developed for a scenario which is without relay. Now let's see the our Pygame simulator, how it simulated it. So you could see in the simulator, we have taken a scenario, we have given the specifications as per 3GPP, and you could see small car, big car, and truck, which is entering into the coverage area of this millimeter wave base station. Whenever they are connected within the coverage area, you could see different data rates they could able to get based on the Euclidean distance and the position at which it was placed. If there is any blockage in between, 3GPP have also defined the blockage conditions which could reduce the data rate of these scenarios. So in this way, the vehicles can be working over. But the problem what happens is, if sometimes there is a blockage in which the point at which the signal can't propagate beyond this, we could use the relay assistance in order to improve its coverage area and also improve its data rate. Next. So this is the simulation environment for the algorithm one. And next, so here, what is the need for relay? We could see there are 4 user equipments if we consider the different positions. Based on the distance, you could see 86, 86, 96, 113, and 119. There is an increase in the path loss. As distance is more, path loss will be more. And what happens is 3 users are in line of sight conditions and other 3 users are non-line of sight conditions. You could see first 3 users are getting a data rate around 7 Gbps of data rate, whereas other 3 users are getting a data rate around 3.4 and 3.7 Gbps of data rate. But here what happens is we could able to connect the user 4 with the relay node. User 3 we could not able to connect with the relay node. So when we connect user 4 with the relay node, you could clearly see there that user 1, if you are using as a relay, the distance becomes 127. So if you see the distance of 119 in the left table, you could see the path loss is 3.4 what we are getting for user 4, which is an online of sight. But when we are using a relay node, we could able to get a data rate of 3.556 Gbps of data rate, which is around 139.96 Mbps of data rate improvement we could able to obtain using this relay node. Next, so what we can see clearly is, next slide. So what we can see is, so identifying this relay, what is the best relay suitable around the vehicle, and based on this probability of line of sight and probability of non-line of sight. Go back once, previous slide. So in this, what happens is, slide changed. Need for relay also. Next slide. So relay node algorithm, if you see, relay node algorithm. Relay node algorithm, if you see the input with the base station locations and non-line of sight and line of sight probabilities we could find, based on the probabilities of line of sight and non-line of sight, we could able to connect these best relay node. So based on which we could able to improve the overall performance of the system. So next we have the simulation result. I'll show that we are done. Yes, sir. Any questions here? So this is the simulation. Yeah. Oh, it's done, sir. I'll come to it in a moment. This is a scenario. You could see the coverage is extended to green circle, other than the black circle, because of this relay existence. So, and more data rate, we could also able to improve the system. Next slide, conclusion slide. So our results clearly states that whenever we have a non-line of sight node for a 5G millimeter wave base station, with the help of this relay node, we could able to overall improvement of the system. So this is we could clearly prove with the respect 3GPP technical specifications which were specified for millimeter wave 5G base stations. Our work is supported under the DST project, what we have currently going on, ongoing project, which is machine learning based intelligent Indian vehicular network based relay assisted millimeter wave base stations for 5G NR. And under this grant we've been carrying out, and I also thank our management which have supported the funding, city funding for this project. Thank you. Next we have reference.
So, Dr. Vinod
Next.
Kumar sir, it's very
Yes,
good
sir.
and very.
Yeah, please.
It seems that it will be a PhD topic for the scholars. So your study is very good, sir.
Yes, sir.
And
Thank you so much, sir.
groups related to relay antennas and all these things. Just one question from my sir. By my MO, you have mentioned in your presentation, MIMO.
Yes, sir.
MIMO.
MIMO.
Yeah. What is it?
Multi-input, multi-output. It's a multi-antenna system, sir. It improves overall diversity of the system from 3G, third generation mobile communications, and from Wi-Fi 4 itself. They are using this technology, sir. So that today using 4G, we could able to download with such a huge data rate using this multi-antenna system. Even in our mobile phones earlier, we used to have only single antenna. Now we are having more than 2 antennas to receive. So because of which diversity improves.
Okay, sir. Thank you so much.
Yeah, thank you, sir. Thank you so much. Thank you for giving such a great opportunity to interact with a P team of researchers. Thank you. Thank you, sir.
What do you,
Thank you,
Ishita ma'am?
sir. I'd like to once again ask for a paper presenter, Akulkar Vivek. Sir, if you're here, then you may start with the presentation. It seems we do not have him in the meeting with us. So that brings us to the conclusion of our ceremony presentation. Sincerely thank all our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters will be getting their digital certificates through email within 2 working days. Furthermore, all the papers have been already forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2025. I'd also like to thank our session chair. Just a second, sir. Professor Shailesh Kahane for chairing the session. A token to the chair on behalf of Team ICT4SD 2025 and Global Knowledge Research Foundation. Thank you for your valuable presence, sir.
Thank you so much.
Just before we end the session, I'd like to request everyone to turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe and take care.
Thank you. Thank you.
Thank you, sir.